This is the untold tale of how the triangle and the square helped uncover the dimensional properties of both our solar system and the atom. In the early 1600s, Johannes Kepler published a 20-year research project into a book called the Harmonics Mundi, or Harmony of the Worlds, where he discusses the harmonic relationships between geometric forms and physical phenomena, such as how the orbits of the planets relate to musical harmony. His reasoning was both incredible and yet simple, and his idea actually has its roots dating back to Plato's Timaeus, where the triangle and the square, being the foundational building blocks of the entire universe, would form the fundamental quanta of matter by constructing one of the 5 Platonic solids, which the ancients said could ultimately describe the foundation of all physicality. It was out of these Platonic solids that Kepler used as units of measurements to determine the elliptical orbits of the planets in our solar system. Now, even though by today's standards his measurements are considered somewhat inaccurate, he was able to determine the orbits of Mercury, Venus, Mars, Earth, Jupiter, and Saturn within about 10% of their true orbital path. The foundation of his work was done by using the then new system of heliocentric astronomy developed by Copernicus a few decades earlier. And it was done by enveloping these Platonic solids within themselves, starting from the octahedron, represented by Mercury, to the cube, which was represented by Saturn. And the orbits of each planet would approximately touch, so to speak, the outer points of each Platonic solid, and that would represent the orbit of that particular planet. Now, another interesting idea of Kepler's model is this notion of the music of the spheres. But to understand this idea, we have to diverge a little bit into astronomy. As already mentioned, the planets revolve around the Sun in an elliptical orbit, but the Sun is not exactly the center of any of these orbits. The term aphelion and perihelion describe the extremes of these planetary orbits in their relation to the Sun, where the furthest distant a planet is from the Sun is the aphelion, and the closest distance a planet is from the Sun is called the perihelion. As the planets revolve around the Sun, they naturally travel faster during perihelion, or when they're closest to the Sun, and slower when they're at aphelion, or farthest away from the Sun. Now, Kepler discovered that when taking the angular velocities, or speed, of a planet at their aphelion and perihelion, and producing a ratio between them, each planet would produce a ratio equivalent to a musical harmonic tone. This is why the planetary dynamics were called the harmony of the spheres, as it is a reference to the planets in action and how their orbits relate to music. This idea also goes all the way back 2,000 years under the classical study of the quadrivium. Even though some parts of this model are considered obsolete today, it did help spring amazing discoveries in classical physics, such as the theory of gravitation by Isaac Newton. Now, fast forwarding about 350 years later into the future, we see the same idea being applied to the microscale of the atom by a prominent physicist and researcher named Dr. Robert Moon, who among other things worked in the Manhattan Project as a key figure in creating the atom bomb. In an article published in 1988, entitled The Geometric Basis for Periodicity of the Elements, Dr. Moon described how an atom's proton, neutron, and electron could be approximately accounted for in space by using embedded Platonic solids similar to what Kepler had done over 300 years earlier. Now, according to Dr. Moon, the first 5 Platonic solids could define a type of limit of what can be perfectly constructed in 3-dimensional space using either the triangle, square, or pentagon, which are the foundational building blocks of the 5 Platonic solids. So the general idea of this model was that the Platonic solids, either by themselves or inlaid with one another, could represent the electron's boundaries within the atom, which are represented by the vertices of those Platonic solids. For example, oxygen having 8 electrons would be represented by the 8 vertices of the cube. So if we circumscribe a circle around the cube, this was meant to represent the electron's boundaries around the nucleus of the oxygen atom. Silicon, having 14 electrons, would be represented by an octahedron which has 6 vertices embedded within a cube which has 8 vertices, totaling 14 vertices altogether. And silicon's electron number is 14. And as a final example, iron, having 26 electrons, is represented by the octahedron, which again has 6 vertices, inlaid with an icosahedron, which has 20 vertices, totaling 26 vertices altogether, and that represents the 26 electrons of an iron atom. Dr. Moon discovered this type of pattern arrangement using the Platonic solids all the way up to the 96 naturally occurring elements of the periodic table, and used a similar configuration for the proton and neutron of the nucleus within the atom to yield a similar result as he did with the electron. This led him to make 2 interesting statements, and one is that space must be quantized, which means that an electron within an atom cannot actually exist randomly, but in fact must have a very discrete orbital pattern within that atom. And secondly, that there's no such thing as empty space. For those of you interested in reading about this article further, I've put a link in the description below. Now, the last statement by Dr. Moon in regards to there being no such thing as empty space is very reminiscent of something I read in Albert Pike's Morals and Dogma, which was originally published in 1871. And the statement in Morals and Dogma parallels Dr. Moon's sentiment towards the end of the final chapter by stating, "There is, in fact, no nothing, no void emptiness in the universe. From the upper to the outer surface of the atmosphere, to that of the sun, and to those of the planets in the remote stars and in different directions, science has for hundreds of centuries imagined that there was simple, void, empty space." Why this is such an intriguing statement from Morals and Dogma is because we oftentimes get the impression that ancient scriptures are outdated or being rendered obsolete by progressive science. And yet, this was written at a time when science believed that the ether or space was a pure void, where in this book, Morals and Dogma essentially concluded what prominent scientists had discovered, so to speak, 100 years later. Now, this is only a few of the amazing coincidences that ancient scripture have in common with modern science. But I want to leave you with this. I'll leave you with this image from the final chapter of Morals and Dogma, and I challenge you to notice some of the details of this 500-year-old alchemical sketch while considering everything we've discussed in this video.